Welcome to homework.
For this problem, they are wanting us to find the average kinetic energy and the average molecular speed for nitrogen and hydrogen. And they are wanting us to do this at standard temperature and pressure. They tell us that they want us to use the R value, 8.314 joules per mole Kelvin. So we're going to be using this R value. And they say that they want their molar mass in kilograms per mole. So for molecular kinetic energy, this is going to be our equation. So we're going to have the average kinetic energy is going to equal 1/2 times the mass times the average U squared. So our average EK is equal to our average kinetic energy. M is going to equal our particle mass, or particles mass. And then 2 is equal to our average of squares of molecular speed. All right. So we also know that our average square of molecular speed is also equal to 3R times T over our molar mass. And we're going to be using molar mass is going to equal Na times the mass, and Na is representing Avogadro's number. All right, so let's rearrange this problem to be able to find out the kinetic, or the average kinetic energy. So let's just substitute EK is equal to 1/2 times the mass of the particle, and let's substitute this for our average kinetic energy, or our average square of molecular speed. So times 3RT over Na times mass, because we're just going to substitute this part for our molar mass. All right, so this is going to be the equation that we're going to be using. And they tell us that the conditions are at standard temperature and pressure. So we know that our standard temperature is going to be 273 Kelvin, and our standard pressure is going to be 1 atmosphere. All right, so let's calculate the average kinetic energy for nitrogen at standard temperature and pressure. So we are just going to substitute all of these values. So we're just going to say 3 times our R value and we're going to times that by our temperature, and we're going to divide this by 2 times Avogadro's number, all right. So our average kinetic energy for nitrogen is equal to 5.6 times 10 to the negative 21st joules. All right, so this is our average kinetic energy for nitrogen, and we're just going to use the exact same equation to find the average kinetic energy for hydrogen. So our average kinetic energy is going to equal 3 times our R value, joules per mole Kelvin. We're going to times that by our temperature, so 273 Kelvin. And we're just going to divide that by 2 times Avogadro's number. All right, so when we calculate this out, our average kinetic energy for hydrogen is going to be 5.6 times 10 to the negative 21st joules. So we see at standard temperature and pressure, the average kinetic energy of nitrogen and hydrogen are equal to each other. So now that we found the average kinetic energy, let's find the average molecular speed. So we know that the average molecular speed is usually given in URMS. And we know that this is equal to the square root of our average kinetic energy. So 3R squared over U. And this is equal to our molar mass. So let's calculate the average molecular speed for nitrogen. So our molar mass of nitrogen is equal to 2.800 times 10 to the negative second kilograms per mole. So if our average molecular speed is equal to the square root of 3 times our R value, we're just going to be using R is equal to 8.314 joules per mole Kelvin. And we're going to times that by our temperature, 273 Kelvin. And we're going to divide this by our molar mass, so 2.800 times 10 to the negative 2 kilograms per mole. All right, and it's important to note that joules is equal to kilograms meters squared per second squared. So when we calculate this out, our kilograms are going to cancel and the squares are going to cancel. So our average molecular speed of nitrogen, when we calculate this out, is going to equal 493 meters per second. So this is our average molecular speed for nitrogen. And then let's do the exact same thing for hydrogen. So our molar mass of hydrogen is going to be 2.016 times 10 to the negative third kilograms per mole. So we're just going to use the exact same equation. So our average molecular speed is equal to the square root of 3 times R times our temperature. And we're going to divide this by our molar mass. So 2.016 times 10 to the negative third kilograms per mole. So when we calculate this out, it's going to equal 1,837.8 meters per second. So as we can see, our average molecular speed of hydrogen is quicker than that of nitrogen because hydrogen is a smaller particle than nitrogen is, so it will move quicker. All right, and that is how we calculate this problem.